Algebra 1 students, welcome to today's lesson 6.6. As you might expect from the last section in a chapter, there are going to be many things that we've seen in the previous sections. We'll start with ideas like graphing lines and inequalities. We're putting it together to graph a system of linear inequalities. Now, I've seen the word system before, where we've solved systems of equations. System of inequalities are a little bit different in that there's not one answer. There's a region where we typically have solutions. So let's take a look at some of these examples. The first problem says to graph the system y is greater than or equal to 3x minus 3 and y is greater than negative 2x plus 4. So where I'm going to start is with the first equation. I know that my slope would have to be 3, and we also know the y-intercept is negative 3. So I'm going to mark the key points here. And then I'm going to sketch the line that would connect those points. Should look something like this. And you'll note that I chose the line, not the dashed line, when I did this. That was in fact intentional because it says that the y is greater than or equal to. Now, rather than shading right now, I'm just going to keep in mind that I'm shading above this blue line, and we'll deal with that in a moment. And if you'd like to, you could even mark it. Sometimes I like to just put little arrows like this. That might be a waste of time for you, so you may say, I don't really like that. I'll just remember that it's above, and if that works for you, that's great. Alright, let's look at the next one. Similar type problem. We're in slope-intercept form. We know the slope is negative 2, and we know the y-intercept is 4. So I'm going to go ahead and mark my key points. There's the y-intercept. Slope of negative 2 would give me some of the points you see here. We could go the other way as well. Again, I need to choose a line. To connect. Now you might note, Mr. Hale, you've made a massive mistake here. And if you know that what that mistake is, that's good for you. You're correct. So the mistake, fortunately I can undo. The mistake is, this says greater than, and I chose a solid line. We know we can't do a solid line when it's only greater than, so we need a dashed line. This should look like that. Okay, the last step on this is it does say that we need to graph the system. We've graphed the two lines. We have not yet dealt with the shading. In both cases, the graphs are above. So my shaded region is this region up here, where we are above both graphs. So that shaded region goes upward infinitely, and any solution to this inequality system would be there. Let's take a look at our next one. Now note this time our system is in a little bit different form. We aren't in the nice friendly slope-intercept form. I'm going to show you two different ways we could approach this one. The first one, I'm going to go ahead and solve for y and show you that methodology and why some of you might like this. I'm actually not a huge fan of this method. I'm going to subtract 2x from each side, then divide everything by negative 1. Do remember that when you multiply or divide an inequality by a negative number, you have to deal with the change of the inequality, as you'll see the greater than change to a less than. So 2x plus 6. I'm going to mark some key points here. Now in this case, I actually need a dashed line to show this graph. That will work. And the key here is this symbol is less than, so I know my shading eventually is going to be below that line. Well, let's see what the other line looks like. That may help us finish the job here. So Now this time I'm going to use the method I prefer, which is by using intercept. So I'll start by saying, well, if x is 0, then what's y? Well, y would have to be 3. And by the same token, if y is 0, we know x would have to be 4. So I'm going to graph those 2 points, 0, 3, and 4, 0. From there, I can simply connect. And you'll note that this time I did use, again, a solid line, which is the correct choice since this graph is greater than or equal to. All right, so let's use I mentioned this method on the last problem and I didn't end up using it, which was fine, but on this problem I'm going to go ahead and use this a little bit more. The first line we said was y is less than, so that means I know the shading has to be below this line. The second line, we're in standard form, so what I want to do is test a point. I'm going to test 0, 0. Now I'm only worrying about the second system or second inequality right now. 0 plus 0 greater than or equal to 12. 0 greater than 12. No, of course not. What that tells me is this point 0, 0 is not part of the solution, so the solution has to be on the other side of this line. Now, the only place where the arrows from both lines point is this region over here. That's where the answer lies. All right. Let's take a look at the next one here. I think this is an interesting one, and some of you may have a different way of graphing the first equation than I do. But I'm looking at it this way. I'm in point-slope form. I know my slope is 1/2, and I know I go through the point -6, 5. By knowing that information right there, I truly have everything I need to know to be able to graph the line. Now again, some of you are more comfortable with slope-intercept. There's absolutely nothing wrong with changing that to slope-intercept form by solving for y. But the line should look like that. And notice this is in fact a solid line, seeing that we're talking about a less than or equal to situation. We'll deal with the shading aspect in a moment. Let's look at the second equation now. Now this is already given to us in slope-intercept. We know the slope is -3, the y-intercept is 5. So I'm going to go ahead and sketch this line. Now again, we have a solid line for the same reasons that we've had before. Whenever you have an equal to situation, not just a greater than or a less than, we're talking about a solid line. All right, now let's figure out where are we shading. We haven't addressed that situation yet. For the first equation, some of you may look at this and be able to think about it in these terms. If I added 5 to both sides and did some simplification, I'd basically be in slope-intercept form, and this is y is less than whatever. So if you're comfortable with that, that'll tell you to shade below. If you're not comfortable with that method, try plugging in a point. Perhaps the origin would be a good idea. The other line's a little simpler. Since it's in slope-intercept form, we can see right away y is greater than or equal to, which means we have to shade above. And the place where the two regions overlap is here. What a beautiful job shading I'm doing. I'm sure yours looks even better though. All right, one more problem to look at. We're going to go the opposite direction on this one. This says to write this system of inequalities for the given graph. All right, So I'm going to look at these two lines separately. I'm going to deal with the blue one first. And let's see what things we can figure out. And right away, I see that we have a y-intercept of 1. And I'm seeing that we have another key point here. So I can see from this that my slope is negative 1/3. So right away, I'm going to go ahead and say, well, then y is, well, what is y? If it was an equation, this would be simple enough. We'd say y equals. But in this case, notice all the blue shading is above. That tells me it's greater than. And it's a solid line, which tells me it's equal to. So y is greater than or equal to negative 1/3 x plus 1. Alright, let's take a look at our second line. The first thing I notice is this point right up here is at 3. That's my y-intercept. And it's a little messy here, so maybe it's safer if I go down to this point. And you can see I'm going down 4 spaces and left 2. Or you could think of it as going up 4 and right 2. So that gives me a slope of 2. That's the information I need. The only other thing to consider is that this is a less than graph. And notice I said less than. I didn't say less than equal to. The line being dashed is the reason for that. So your system should look something like this. Alright folks, I hope that helps you. If you have questions, bring them to class and we will discuss from there. Have a lovely day.